let's fill out these notes for 1-2 properties of numbers. There are a few algebra properties that come in handy once we begin solving equations. We're going to review some of these. The first one is the commutative property. I want these property names to stand out to you because you're going to need to write them down with some problems coming up. So let's go ahead and circle that. Commutative property. Does it matter what order you write numbers in when you are adding, subtracting, multiplying, and dividing them? Let's find out. Let's use the numbers 5 and 10 and determine if the order of the numbers matters. Let's see. So with addition, does 5 plus 10 equal 10 plus 5? See, I moved the numbers around. I changed the order. All right, 5 plus 10 is 15. And if I move the numbers around and do 10 plus 5, what do I get? I also get 15. So these two answers are the same. So the answer to this question, does 5 plus 10 equal 10 plus 5? That answer is yes. Let's look at subtraction. Does 5 minus 10 equal 10 minus 5? Well, let's see what we get. If you started with 5, like 5 degrees, and the temperature dropped 10 degrees, where would you be? You would be at -5. But here, if you have 10 items or 10 degrees and the temperature drops 5, you'd be at 5 degrees. These two are not equal. So the answer to this question is no, they don't equal. Let's look at multiplication. Does 5 times 10 equal 10 times 5? Does it matter if I change the order? Well, 5 times 10 is 50. 10 times 5 is 50. These are equal. So yes, they're equal to each other. And let's look at division. Does 5 divided by 10 equal 10 divided by 5? And in hindsight, instead of writing it with the division symbol, I should have written it this way, 10 divided by 5, because I need you guys to be accustomed to this division bar. Well, what is 10 divided by 5? That's 2. But here, 5 divided by 10 would have 5 on top and 10 on the bottom. Well, this is the fraction that reduces to 1/2. Or if you put this in your calculator and do 5 divided by 10, you'll get 0.5. These two are not the same. So no, they're not equal. If the order did not matter and you got the same answer either way, then circle the operation. Well, that worked for addition and multiplication, but not subtraction or division. If the order of the numbers did matter and you got a different answer, then strike through. That's what we've done here. So from this, we see that the order of the numbers does not matter when we are adding or multiplying. When you are adding or multiplying the numbers, when you are adding or multiplying, the numbers can commute or move around. An example of the commutative property of addition is, all right, suppose I gave you the problem 3 plus 8 plus 7. Now, I know from learning my fact families that 3 plus 7 gives me 10. Well, it's much easier for me to add these together to get 10 and then do 10 plus 8 than add them in the order here. So what I would do, either in my head or on paper, I would move it around. I'd move the 7 up here, do 3 plus 7, and then add 8. It's the commutative property that lets me do that. An example of the commutative property of multiplication is, all right, suppose I gave you 2 times 7 times 5, and I asked you to do this in your head without a calculator. Well, 2 times 7 is 14, but it's not easy for me to do 14 times 5 in my head. But once again, when I look at these numbers that are being multiplied, I recognize something from my fact families. I know 2 times 5 gives me 10. That's pretty easy. So I'm going to move them around. I'm going to move the 5 up here and do 2 times 5, which is 10. And then 10 times 7 is easy. That gives me 70. So it's the commutative property of multiplication that would let me change the order of the 7 and 5 and do it this way. So that's the commutative property. We have another useful property that only applies to the operations of addition and multiplication. This property says it's okay to change the way numbers are grouped together. And next to the word grouped, write some parentheses because that's what we use when we're grouping things together. This property is called the associative property. An example of the associative property of addition is, well, suppose I give you 8 plus 2 plus 9. And I asked you to do this without your calculator. Well, these two numbers right here, 8 plus 2, is part of the fact family for tens. I'm not going to change the order of the numbers, but I'm going to be able to work this out easier if I group the 8 and 2 together and add them first and then add 9. The numbers didn't change order. Instead of these two grouped together or associated together, I changed it and grouped the 8 and the 2 together. So that's the associative property of addition. Notice that the order of the numbers didn't change, just the grouping of the numbers. An example of the associative property of multiplication is, well, suppose I gave you this problem, 5 times 4 times 9. Well, let's see, 4 times 9 is 36, and 36 times 5 would be hard to do in my head. But as I look at these, I go, I can do 5 times 4 pretty easily. 5 times 4 is 20. And then I can multiply 20 times 9. I know 2 times 9 is 18. So 20 times 9 is 180. So once again, the numbers did not move around. They're still in the same order. The only thing that changed is the way they were grouped together with parentheses. All right, one of the most useful properties in algebra is called the distributive property.